Okay, so if we are looking at the LMR16006, then I would start with whatever says unencrypted. So the unencrypted one you'll be able to read, and if you're able to read, you should be able to use it easily. All these are Pspice models, so you don't want to go too much into the specific Pspice model. It should work on LTSpice, however, so this is what we're going to try to see. So this is the one I've downloaded. So if I look at the unzipped version of this, I've put it on my desktop and I have a library file. So if I look at the library file, then there are multiple things that are included. One is the subcircuit of the transient CB itself, and in addition to that I have a lot of other smaller items that are probably included: driver, oscillator. So if you just look at the syntax of what, let's say, one line looks like, it says there's a resistor between ground and 0 of 1 milliohm. So that's sort of what each line indicates. If it's an R, it's a resistor. If it's an E, it's a voltage control voltage source. If it's an X, it's an element that has a special model, which he has included here. So you actually need all of them. You can't just include one of them. And this, it will also have some information on the top. When we actually need to make it work, we'll also need to read that, which it says here, that you have to set SS to 1, and if its SS is 0, then you will have startup. It will take 3 milliseconds just to get started. Otherwise, okay, I'll just read it out. The soft startup time is internally fixed to 3 milliseconds box. To run the steady state simulation is after something starts up, which is what we really care about. He says set steady state to 1, otherwise set steady state to 0 to observe startup. So we'll figure out how to set that later. So this is a library file because it's not just one subcircuit or one model, but we can look at briefly look at what are the subcircuits. So these are all the subcircuits that are there in this model. It has comparators, AND gates, NAND gates, NOR gates, inverters, XOR gates, latches, D flip-flops, the works. Okay, so it has all these things that are already there. So I can't just include one model. I need the entire library for it to work. So the first thing I'm going to do is I'm actually going to just copy it over, and which is what I have done here. I've copied it over to this is where my LTSpice is installed, and if I go into the subs, which is where all the subcircuits are, I've just copied this file over here. Next, from inside the LTSpice, I have just set file open, and I have gone to this directory, desktop Pspice, this directory, and then I select show me all the files, not the ASC files, show me everything, and then I've selected library, and that's what this is. So in LTSpice, if you want to include a new model, I think we've already sent this out, you can create a symbol for it. So we just create a symbol for it, so that's done. And then I'm going to see if I can include it. So with the symbol ready, I should try to use it and see what happens. So in order to do that, the first thing I would do is I would go to its website, and it has the datasheet, so I would download the datasheet. And if I look at the datasheet, it tells me what it is. It's a buck regulator. I can have a wide range of inputs, and I can then decide what kind of output I want. So what kind of output, how is it figuring it out? It has, if I look at this simplified schematic, I can see the input is supplied. It goes up to 60 volts. There's a ground, this I can understand. It has boosting capacitors, so there must be some range on the kind of capacitor I can put. It has a Zener diode that fixes the voltage. Then it needs the inductor for the buck boost functionality. That's an external inductor. And then This is a typical usage. This is your C out, this is the output going out, and then the output has a resistor divider which goes to the feedback. So that's probably how you determine what kind of output voltage you want by changing the resistors. So if I search for R2, I find the output voltage setting V out is decided by as 0.0765 volts plus into the ratio of the resistors 1 plus R2 over R1. Okay, so R2 he wants more than a kilo ohm. And to solve for R1 given an R2, so let's say we fix an R2, make it 10 kilo ohms, it's right in the middle of the range. So then R1 should be equal to, so R2 divided by V out something. So we trust Python, and in Python we put in the equation. So I have already decided R2 is 10k, so I just say that R2 is equal to 10k. Then I have R1 that I want to find out. So what's the V out I want? Let's say I want 5 volt output. So I'm going to have R2 into V out. Also I'll make it a variable so I can move it around. And so now I have and back to this. So this gives me around 5.5k. Okay, so I put R1 as 5.5k, I put R2 as 10k, it should give me around 5 volts. Okay, so now I need to include it. This is just a symbol, I don't care about that. I'm done with that. Okay, and then I just start a new schematic, and then I include the, there you go. It will be under the auto generated because I just generated it. I can place it. I can place my ground. Then I can place my input voltage. So made it 15 volts. So I just moved it down a bit so it looks a little clean. Okay, so then we go back to where we started. The first picture, and see here that okay, I have done the ground and I have done the input voltage. So I should add a small capacitor, but that's not necessary for me. I've already put a voltage source. Now I need a capacitor between CB and SW, so that I'll have to look out for, and I need an inductor. So let's just put the resistor network. Let's just put a network that looks something like this. So I just pull this out further, and we put so maybe a diode or a Zener. I don't know if Zeners are there. Yeah, they're there. Okay, so I put a Zener. I put a Zener. Ground it. So I just put a search for L1. I see some typical value. Looks like it's 22 micro. So that's what I'm going to use. Okay. Then I go back and look at C out is 10 microfarads. It's a cap. Then just to remind myself of the circuit, I go back again, look at it. Yeah, the resistor divider is at the same node. Okay, resistance. I have. How do I do this? So I get the resistor. This one. There's the other, and I make them 5K and 10K. And then I have to put the label, so I call that feedback, just there, and I copy that to here, and that to there. Well, then I need to know what is CB and shutdown. So back to my thing. Okay, CB, and we need something called cboost. So I keep searching for that cboot and say the 100 nanofarad capacitor. So capacitor, in which I'll have, okay, between these, and should be a shutdown bar. That's what it seems to indicate. Maybe they didn't know how to draw a bar. So 100K. So a resistor of 100K between that and input. Okay, there you go. Of course, your application may be a little different than this. So now the question is, does it work? Okay, so I put a dot transient, and I also change the capacitor values, and now if I run the sim, it says it had trouble parsing that initial condition of that voltage SS. So let's see. So I exit my Python and I edit this file and see what exactly I'm supposed to do with that SS. So it's not entirely a surprise, because it said application note, you have to set SS to 1 or 0. So what I'm going to do is just add a voltage source, and so V of SS, and I'm going to make it from SS to ground or SS to 0, ground, let's say SS to ground, and I have my voltage value of 1 volt. Okay, so I don't know if I need to reinitialize it. Okay, so that didn't work. That's not what you're supposed to do to use this model. If you look at it, it says trouble parsing initial. Parsing is usually so there's already something that's setting the value and it's not happy with it. That's what it means. Okay, so we need to look at the file again. So if I look at the file, it's setting the initial value of SS based off the parameter SS into 1.7. So maybe it's a parameter I need to set. So the first thing I should do is remove the line I added. That's not smart. They must have made it already usable. So I'm going to look for what to do with parameters. So when you call the models, you need to give it parameters. Quite a few of them. Okay, so we have to set that parameter with this cell. That's basically what's happening, and so that's what I've done here. And the spice line, I have just set SS is 0. I needed to make one more correction. I need to put the diode model. And so if I run the simulation, okay, well, that's too much. You can't see much, but I can see that this guy is slowly building up. So this is starting from the initial value of 0. Okay, so what if I'm going to set the SS to 1, so that tells me it's a steady state value, and then run the simulation. So now if I look at feedback, okay, it's still doing, slowly stabilizing, but the voltage is building up. I mean, it's clearly taking some time to set it up, and whether it will come to the right voltage or not, of course we'll have to see in time. But in terms of being able to use the model and just including the model and being able to run the model, I hope this clarifies how you do it with a third party Spice model.